I represent here the packaging part. So aluminium end-use products are also, of course, in automotive, in building, and numerous other applications. Even the latest, the rover which landed on Mars a few days ago, the wheels are made of aluminium. So we have now aluminium on Mars.
Great.
I hope it will be once recycled when a manned mission will be sent to Mars. Okay, when you look at packaging, you can see the various products, obviously the beverage can, but also the chocolate foil, the closure on wine bottles, maybe even on the Romanian wine, the famous coffee capsules, although officially, according to EU legislation, it's not packaging, it's a product, but most people perceive it, of course, as packaging. So I talk on behalf of the producers of what we call the semi-fabricated can and foil sheet, but also the guys who recycle it. So we want to get it back. And in the case of Romania, for example, we already buy the used beverage cans from Romania, and we remelt these in facilities somewhere else in Europe. And then hopefully the can comes back to Romania in just a couple of weeks. For us, the circular economy is, I think, extremely important. We need to keep aluminium in the loop, in the circle. And when you use it, the use phase here at the left hand, it should be collected, preferably separately and not mixed with other waste. Then it goes to a sorting and treatment facility, and then we can remelt and refine it. This means that we have to maximize the collection of all available aluminium, that we also have to invest in better sorting and treatment technologies, and also improve the remelting process. When you look at the challenges ahead of us, you can see that actually we have to meet these new packaging recycling targets set by the European Union for 2025 and 2030. These are 50 and 60%. That looks rather low, but in reality, it's quite challenging because you have to achieve real recycling and not somewhere halfway down. So somewhere during the sorting phase. No, you have to prove that it is actually going into a furnace. And that's the point of measurement. And for the beverage cans, I think we are already doing a great job. 76% of all aluminium beverage cans in the EU 27, plus the UK, plus EFTA, are being recycled today. But that's not the case for all the other aluminium items. There we have, I'm afraid, a much lower performance. So we need all available collection systems and sorting technologies to achieve this. And everybody in the supply and waste management chain has to take up their responsibility and to make the right investments, preferably as soon as we can. If you look at this slide, we urgently need harmonized collection systems at national and preferably even at European level. So consumers are often confused by all the different systems. In country A, the color is yellow. In the other country, it is blue and then maybe green. In one country, you can put in the cans together with the PET bottles and the beverage cartons. In another country, you can also add the foils. So it's rather complicated. It can be even different from city to city in some countries. So we need to put at least some clarity into those systems and to make it more convenient for consumers. We also have to invest in the latest sorting technologies and the use of what we call advanced separation tools. And in the case of aluminium, we talk about eddy current separators. It's a kind of magnetic extraction system for non-ferrous metals, like the magnet for steel. You have the eddy current for aluminium. Then very advanced equipment like induction sensor and robot-based sorting technologies. These are available. And the interesting thing is that we made a study of this with the help of a German consultancy called HTP. I think they also consult the city of Bucharest for their sorting plant. And I would like to show you a few slides, what they actually can do in terms of calculating things. So what you need is to have a simple and accurate sorting calculation for waste, for packaging waste, for aluminium packaging waste. And then you can develop a cost model with total and incremental of the technical measures needed. And fortunately, aluminium, due to its high value, because it's a material which can be circulated endlessly, it comes back after each recycling trip. We can set off those investments basically by the value of aluminium. That's the interesting part. For other materials, this is maybe less obvious, although if you have very clear, well-sorted PET, then of course you also have a high scrap value, and there are a few more, but aluminium has the highest scrap value. So if you look at a sorting plant today, it is a rather complicated view. I will not go into the details of this because people might not understand it, but this is a typical municipal recovery plant where with an average capacity of 80,000 tons per year. So when you look at the aluminium fraction, you have to make a distinction between what we call super fine material, medium low, medium, etc. And for each type of material, you can see you need different tools. You need that eddy current sorter. You need maybe that sensor-based sorting equipment, or even a robot, if you can afford it. We found out, and it's just a short summary of the conclusion of HTP, that you need, in any case, you need a second eddy current separator. One is already enough for the bigger fraction, but if you want to collect also the smaller parts, take those coffee capsules or a small tray or a wine closure, you need this second eddy current in a material recovery facility. And what you will see, unbelievable, you will immediately see that 30% more will be sorted, and you move from 60 to 90% of your material sorted. You can even sort an additional 4 to 6% by introducing a sensor sorter and a robot sorter. And the depreciation times of these tools are relatively low. So for a second eddy current, you have a payback of just half a year. For a sensor-based sorter, 3 years, and for a robot sorter, nearly 4 years. So that is relatively quick. And that I come to almost my last slide. It proves that this is also an economic thing. If you invest together with us into that European circular economy, it really pays off. And aluminium, alu, is value. And if people realize this, I think they will also make that investment. And this is the problem or the challenge for me, that not everywhere people realize that you can really make money with the circular economy. If you take the right decisions, if you innovate, if you invest in new collection and sorting facilities, you can really make money. So if you have questions, then you can ask them right now.